Here's section 3.3, exercise 38. And in this case, we're given a piecewise defined function, f of x is 2x plus 1 when x is less than or equal to negative 1. And then it's x squared minus 2 when x is greater than negative 1. Okay, and we're supposed to find the critical numbers. Well, so I'm going to find the derivative, and f prime of x is equal to, and I'm just going to do each part. So the derivative of 2x is 2, and that's when x is less than or equal. Well, actually, we got to be a little careful there. Right at the moment, all I know is when x is less than negative 1. Because equal to, I'm going to have to check limits to make sure at negative 1, x equal negative 1, things match, the derivatives match. Well, so then derivative of x squared minus 2 is 2x, and that's for x greater than negative 1. Now the question is, when x is negative 1, do I get 2 from both of these? And that would tell me the limit worked out for the derivative. No, they're not, right? Because here, the top, if I evaluate that, I definitely get a 2. But in the bottom, when I evaluate that, I get a negative 2. So right away, that tells me one critical number is at x equal negative 1. And notice I leave that as a strict inequality because the derivative is undefined there. Okay. But now I also need to look for when f prime of x is 0. So at x equal negative 1, since f prime of negative 1 is undefined. And then, let's see, 2 is never equal to 0. But if I set 2x equal to 0, I get x equals 0. Oops, x equals 0. Okay, so my critical numbers are negative 1 and 0. And so then in part B, I look for whether they are increasing or decreasing, the derivatives increasing or decreasing between those. So there's negative 1, there's 0, and I need to check the derivative in other places. Well, I know to the left of negative 1 from this, well, it's always 2. Okay, so that's always positive. Then, between negative 1 and 0, okay, so I'm in this part as soon as I'm to the right of negative 1. And so let's try at negative 1/2, right? And if I put any negative number into 2x, I'll get a negative number out. So my derivative is negative here. So, f prime was greater than 0 here, f prime was less than 0. And then finally, to the right of 0, well, 2x is always going to be positive to the right of 0. And so this is plus, and so f prime is greater than 0. Okay, so my intervals for increasing and decreasing, all right, increasing on minus infinity to negative 1 and 0 to infinity, and decreasing on the interval negative 1 to 0. Okay, so we know where it's increasing and decreasing, and then so for part C, I want to decide maxes and mins and all that, so -1 and 0. And it went positive, so it was going up, and it was going down, and then it was going up again. And the function, even though this critical number here at -1 came from the derivative being undefined, the function is defined there. And so this is a relative max, and this is a relative min. If the function had not been defined at -1 here, then I would have said neither. But it is defined, and so that would be a relative maximum there. And it will just be, maybe have a point or something like that. And so there are my relative max and mins. And then again, part D, I go take a look at it on Desmos. And there I've graphed the function. Let me see if I can, I don't know if I can make this wider. I'm trying. You can't see me trying. I'm trying real hard to make it wider. I can't, I'm not sure. Oh, there, I got it. Okay. There, I made the input box wider. So you can see how I put in this piecewise defined function. I put in the x is less than or equal to -1 first, then did a colon, and then gave the definition of the function for that domain, 2x plus 1. Then a comma to separate things out, and x is greater than -1, so the other part. So unlike the way we tend to write it, when we write things, we usually write how the function is defined first and then give the domain. In Desmos, you give the domain, colon, and then how the function is defined, and you put it all in those curly braces. Okay, but once you do that, whoops, I seem to have lost the function again. I don't know why that does that, but anyway, there's my function, and we do see that at x equal -1, we have a relative maximum, but it is a point, and so the derivative is not defined there. And then at x equals 0, we have a relative minimum, and again, we can see by plotting f prime of x, it was 2 everywhere to the left of -1, and then it was negative from -1 to 0, and then it was positive from 0 on out. Okay, so there's number 38.